Strong acid is going to have the same level. And so this is it. If you're going to take apples from a tree, which ones are going to be the easiest? The lowest ones, right? The lowest ones are going to be the easiest. And so the strongest acids are going to be like the lowest apples. Water is the person trying to grab an apple from the tree. And so water will have an easier time. That is, this person will have an easier time plucking the lower apples off the tree. But there's a certain level. So the lowest are the easiest. So the lowest would be like perchloric acid.
Yeah.
But there's going to be a certain level. Let's say this person has a little ladder, and they can reach all the way up to this level. At this level, we're going to have what's the nitric. And so this would be like HClO4. This would be like HNO3. And so these are easily reached, and therefore this person can clean off all the apples from the tree. In other words, this person, the analogy goes like this. Water can pluck all the hydrogens off these acids. If water plucks off all the hydrogens, then they're all the same. You know, even though this one's easier to pluck off, water has no problem plucking them all off. Now, once we get to weaker acids, then it makes a difference. And so the very weak acids up here are very difficult to pluck the hydrogen off. The stronger weak acids, we can pluck more hydrogen off, but not all of them cleanly. And so all these can be plucked clean, but when we look at here, there are going to be some remaining apples, so maybe they'll be able to jump up and grab a few of these, but for the most part, they can't grab them all. And so what a weak acid, when we have a weak acid, is, well, what we're doing with the ionic equation is we're doing the major species. And so if we take a weak acid like nitrous acid, HNO2, then what we see here is that when we put this in water, water can only take some of the H's off, not all of them. And so what we end up with is this kind of situation where this is the major species. These are the minor species. And so that would be like on this row here. You know, this is above this level, and so it's able to take some of the apples because these are hard to reach, but not all of them. And so this person has to jump up and grab them and get lucky in order to get them. And so for something like nitrous acid water really doesn't remove the hydrogens completely off. Whereas something like hydrochloric acid, water has no problem removing all the hydrogens off here. And so for hydrochloric acid, this is the major species. In fact, we don't expect any hydrogens to remain. Whereas something like a weak acid, no, we leave it together. And so you do not break apart weak acids. You only break apart strong acids because water is only capable of removing the hydrogen off species that are most easily.
Okay.
So 39 and 40 are pretty much the same. So do 41, and then 42 and 43 are different actually. And so you want to do like this. Can you write those down? Because we also want to do this one, magnesium carbonate and HCl. Magnesium carbonate and HCl. We don't have that much time. We'll try to get those. Do you see an error with this? Number 45?
Error number 45?
There's an error in number 45. Do you see it? It's a typo.
It's the aqueous?
Yeah.
Yeah.
Do you guys see that? Number 45 is wrong, but you could fix it.
What is wrong?
We'll try to figure it out.
One of them's not the right? Yeah, maybe because I think it's true.
So,
Yes.
Carbon says soluble stone.
Oh.
Manganese and carbonate is not solid.
Yeah.
So it should be S.
yep. Right. So, it's a wrong. It's an error.
Okay. Is this due present?
These are your homework problems. They're due, yeah, they're going to be due with your homework. Half of them are your homework problems. You know, the ones with the answer are the ones I assigned. But we can get additional practice with these. So,
Tomorrow we have lab. And then next week are we gonna do any review for the?
not really. I mean, just, we aren't going to spend as much time reviewing as we did for the last test, but if there are questions, we'll do it. Yeah, if there are questions, well, I can review those topics, but it's not going to be a general, all-around overview. Review. Yeah, this is going to be due. Actually, you have more than this. We're going to do more. Tomorrow, we're going to do redox in addition, and so we'll complete the rest of this homework assignment for that. But I'm staying, so go ahead. If you want to work on these at home, it's fine. How to do 39? What do you have so far?
Categorize them.
Okay. Did he show you how to do the driving course for 39? Or figure out the product for 39?
The whole thing, maybe?
Huh?
The whole thing?
The whole thing?
Yeah.
The whole thing?
So I'm missing those two labs.
Oh, we can talk again. We can talk in the lab. It's not over yet. Class is not over. We can talk. Class is over officially when? 1:05. So let me just. Okay, so number 39, we have sodium nitrite, NaNO2 plus HI. Then, are you familiar with this? AB, were you here yesterday?
Yeah.
Yes.
AB plus CD?
Yeah.
We just flip them. And so what does it form?
For NaI.
NaI plus
And then nitrous acid.
nitrous acid. This is soluble, this is soluble, so both of these are aqueous.
Yeah.
So we look for the next one, stronger to weaker. And that's the case here. Hydroiodic acid is a stronger acid, this is a weaker acid. And so we call this a driving force. Now, for this one, I didn't, you don't have to write AQ, but you can. All these are aqueous. But just because they're aqueous doesn't mean they'll dissociate. This is a soluble salt, so that's going to break up into the ions. This is a strong acid, so strong acids lose the H plus easily, but weak acids don't.
The part that you're doing right now, that is the ionic equation?
Yeah.
Okay.
So this is the CE, this is the ionic equation, IE. This is soluble salt. The salt lattice breaks apart here. And then this is a weak acid. Weak acids, the hydrogen isn't
It's
lost
not break apart.
so easily, so it doesn't break apart. Water is not strong enough to pull off the hydrogen ion. Water is not strong enough, but that's all we're looking at here. When we do the ionic equation, we're looking at what water can do. Other chemicals are strong enough to pluck off that hydrogen, no problem. If I had a base that's stronger than water, it'd have no problem pulling out that hydrogen, but water can't. And so sodiums don't do anything. iodides don't do anything, and so the NIE for this is just hydrogen ions plus nitrite ions yields nitrous acid.
Okay. So it's nitrite plus hydrogen.
Yeah, hydrogen ions, like nitrite ions, they form nitrous acid. This is sodium nitrite, hydroiodic acid, sodium iodide, and nitrous acid.
Okay. Yeah, nitrous acid. Yeah, it's right there. It's going water from that thing. Yeah, yeah.
These are your homework problems. However, I'm asking for a lot more than your book asks. Your book only asks for the net ionic. Your book doesn't ask for the driving force. I want the CE, IE, NIE plus driving force. So it's a bit more than what the book is asking. So give 41 a shot. Yeah, 41.